So we're all living in this age of AI, right? But let's be honest, a lot of the time, it feels like the AI isn't, well, it's not quite living up to the hype. In this explainer, we're going to dig into why our AI assistants so often fail and explore a new architectural blueprint that promises something we desperately need: trust.
Oh, you know the feeling. We've all been there. You're just trying to solve a simple problem, but you find yourself stuck in this digital dead end, just going in circles with a bot that does not get it. It has to be one of the most frustrating experiences with modern AI.
But here's the thing. What if the problem isn't that the AI is dumb? What if the issue is actually much more fundamental? What if the very foundation that most of these chatbots are built on is just brittle, inflexible, and not really designed for the chaos of the real world? The problem isn't the intelligence, it's the architecture.
Okay, so let's get into the nitty-gritty of it. We're going to start by looking at exactly why these systems are so fragile. And it all comes down to a concept called the linear chain. Think of a standard chatbot's thought process like a one-way street. It takes your request, it moves to the next step, then the next, always pushing forward in a straight line. Now, for a super simple question, that's fine. But real conversations? They're rarely one-way streets, are they? In this whole one-way thinking, it has some serious consequences. I mean, if the bot makes a wrong turn, there's no easy way to go back. If a tool fails, it has no idea how to try something else. It completely forgets what you talked about 3 messages ago, and if things get just a little too complicated, there's no simple way for a human to jump in and take the wheel. It's basically a recipe for failure. You know, when you put them side by side, the difference is it's night and day. The old way, this linear chain, it's rigid, it's fragile. Everything from managing the conversation's memory to letting a human step in has to be bolted on with clunky custom code. But the new way, this graph architecture, it builds these critical features right into its DNA from the very beginning.
So, if the one-way street is the problem, what's the solution? Well, this brings us to a major paradigm shift in AI design, and it's being championed by a framework called LangGraph. It's all about learning to think in graphs.
So let's just leave that one-way street behind. Instead, I want you to imagine a detailed city map. You've got multiple roads, you have intersections where you can make decisions, you've got roundabouts where you can loop back and reconsider things, and landmarks that help you remember where you've been. Now that is the mental model for a graph architecture. It's dynamic, it's flexible, and it has memory.
So, how does this actually work under the hood? Well, LangGraph treats the whole workflow as what's called a finite state machine. A simple way to think of it is like a board game. The AI agent is a piece, and it can only be on one square, one state, at any given time. Every new piece of information you give it is like rolling the dice, and that moves the agent to a new, logical state on the board. It makes the entire process structured, predictable, and incredibly powerful.
And this all comes together in this really smart, continuous cycle. First, the agent looks at the current state of the conversation. Then, the large language model decides what to do next. Should it talk back to you, or maybe use a tool? The graph's edges, or its pathways, then route the flow based on that decision. And finally, whatever happens, the result gets saved to that central state, and the whole cycle just begins again. It's a continuous loop of reasoning. Now, this new architecture doesn't just make the AI smarter, it makes it safer. And that is absolutely critical when we start giving AI the power to perform real-world actions for us. I mean, really think about it. This is the kind of high-stakes interaction that gives developers nightmares. How do you build an AI that you can actually trust not to accidentally cancel the wrong flight or update the wrong record? One little mistake could be a complete disaster. The answer, it turns out, is actually pretty elegant. You don't just hand the AI a giant box of tools and hope for the best. Instead, you strategically divide the tools into separate toolkits based on how much risk is associated with each one. So you have your safe tools. These are just for reading information, like looking up your flight details. They literally can't do any harm. But then you have your sensitive tools. These are the ones that make changes, they update things, they delete data. The system is designed so that whenever the AI wants to use one of these sensitive tools, it knows, hey, I have to ask for permission first. And that brings us to what is, honestly, the killer feature of this entire architecture. It's the ability to seamlessly pause the AI and bring a human into the loop, creating a true safety switch. Now, this is all made possible by a process called checkpointing. Every single time the agent takes a step, any step at all, it automatically saves a perfect snapshot of its entire memory and its current state.
This means the process can be paused for minutes, hours, even days, and then be resumed exactly where it left off, without losing a single drop of context. And here is the key. The system doesn't wait for a mistake to happen. It's smart. It proactively identifies the intent to perform a risky action, and it pauses before it can happen. What could have been a potential error becomes just a simple moment for a human to give a thumbs up or a thumbs down. So the workflow is super simple and really effective. Let's say the AI decides it needs to cancel a ticket. The system immediately hits the brakes, interrupting the flow. A human reviewer can see exactly what the AI wants to do and why. They click approve, and only then does the agent resume and complete the action. It is safety by design. Now, this safety-first design doesn't just improve one agent. It's the key to unlocking something even bigger: intelligent teams of AI agents that can work together to solve truly complex problems. See, the goal isn't to build one giant monolithic AI that knows how to do everything. That approach just doesn't scale. It becomes unreliable. The future is in creating smaller, specialized agents, each one an expert in its own little domain, and then teaching them how to collaborate effectively. It's a lot like a well-run human team, right? You have a supervisor agent whose only job is to understand the user's request and then route it to the correct specialist, like a flight expert or a cancellation expert. Each specialist only has the tools it needs, which makes it faster, more focused, and way less likely to make a mistake. It's a beautifully efficient way to manage complexity. So we're left with this pretty powerful idea. Our most advanced AI might just be at its best when it has a human partner. This isn't a future of replacement, but of collaboration. A future where human and machine intelligence work together in a way that's powerful, transparent, and most importantly, trustworthy. And that sounds like a future worth building.